Welcome to the online lectures for software engineering. In today's class, we'll be discussing class-based modeling. That is the class diagram. Now, class diagram, it is a structural diagram. It is going to represent the structure of the system that you're going to represent or that you're going to make. Now, within class-based modeling, there are four criteria that we are going to study: identifying the analysis classes, specifying attributes, and operation. Now, these three things are what makes your class. Now, within the class, the first compartment is going to be the class name, second is going to be attributes, and third is going to be operations. So this is what a class is made up of. Then the next that you're going to study is CRC modeling. So the first one is identifying the analysis classes. Now when you are identifying the analysis classes means how you're going to identify what are the different classes. Now when you identify the analysis classes, we are going to perform the grammatical pass. Now within the previous classes also, we have seen when you're converting the DFT diagrams from level 0 to level 1, we are going to perform a grammatical parse upon the narrative. Now the same thing, we are going to perform a grammatical parse upon the narrative to identify the classes. Now when you're identifying the classes, what you're going to do, we are going to identify all the nouns, and if any noun clause are there, that are going to be identified. Noun clause are going to be identified. These are going to be your classes. Now, when you identify all the particular classes, when you identify if a class is required to implement a solution, then this becomes a part of your solution space. Then if a class is necessary only to describe a solution, then this becomes a part of your problem space. So you identify the classes by performing the grammatical parts on the narrative. Nouns and noun clauses become your classes. And if a class is used to implement a solution, then it is part of the solution space. Implement a solution. If a class is used to describe a solution, then it becomes part of the problem space. Now, the next is how you're going to identify what are the different analysis classes. To identify the different analysis classes, these are the following ways. The first one is external entities. Now, external entities means any system, any device, or people. These are your external entities. Then the next is things. What are going to be things? Any report or any signal is your thing. That is, these are going to be your analysis classes. Now, these signals or reports, these are part of the information domain. What information that you're using, that is your information domain. Then the next is occurrence of event. Now, occurrence of a particular event means if suppose you're using a robotic, if you're developing a robotic application, then a completion of a series of robot movements, this becomes an occurrence of a event. Then the next one is roles. Now, roles are, it can be a manager role, it can be an engineer, or it can be a sales person. These are the different roles. Then the next is an organization unit. An organization unit, it can be a specific division or a group or a specific team. These are your organization units. Then the next is any place. A place, it can be a warehouse. Then the next is structure. Now, what is going to be a structure? A structure, it can be any sensor or a computer. Now, these sensors or computers, these are going to define the class or object. These are used to define a class of object. So these are your different analysis class. These analysis classes can be manifested in these different ways. Now, the second step was specifying the attributes. Now, when you're making use of attributes, what are attributes? Attributes describe a specific class. Attributes are going to describe a class. Now, for this particular example, if the class name, this is your class name. Class name is system. Now, attributes means what are the things that are going to describe your system. These are the things that describe your system. That is a specific ID. A system is going to have a specific ID, a specific serial number. Then a verification phone number, the status of the system, whether it is working or not, any delay time, how much, within how much time it gives you the result. Then the telephone numbers, a master password, a temporary password. Now these master password, this is for the admin. Temporary passwords, if you're giving any temporary passwords for some specific files, you're giving those passwords, circulating this password to users that can use the particular file temporarily. Then the number of tries. Now these number of tries, these are associated with the invalid entries. How many invalid entries are accepted? So these are your attributes. Now after attributes, we have got the different operations. Now what are operations? Operations are going to, one second. This is the third one. Third is defining the operations. Operations, they define the behavior of an object, how a system behaves. Now first we have seen what a class is, then what is going to describe a class, and then the third compartment is going to be the behavior of a class. Three compartments. This is the class name. Second is the attributes. Third is going to be the operations. So you're going to have four broad categories of operations. Those four broad categories of operations, these are used to manipulate the data. Now operations are used to manipulate data, changing the data. Operations that perform a computation, that is your processing information in here. Then next is operations that inquire about state of an object, if suppose you are displaying the data. Then the next is operations that monitor the object for the occurrence of the controlling event, like you're accessing the data. Now we'll see an example. This. Now this, for the system, you've got the system ID, verification phone number. These we have seen with an attributes. This part is your operations, like you're programming the system, displaying, reset, query, arm, and disarm. You can see that all of this are used for manipulating the data or displaying the data. These are the different functions. Now, this is the representation. This is an example for class diagram for a floor plan. Now, floor plan, for the floor plan, we have identified the different classes. You've got 1, 2, 3, 4, 5, 6 different classes are there. Now, these 6 different classes, you're going to identify the different relationship. For a floor plan, that is within a floor, you're going to have different cameras for safeguarding for safeguarding the place after it is developed. You're going to have different walls. Now a wall is going to have wall segments, windows, and doors. Now we'll start from the wall. Now a wall, is going to have, there's going to be different dimensions for the wall. There is going to be a type of wall, whether it is a fall wall, what type of wall it is, you're going to have that. Then an operation for that wall is going to be, you're going to determine the type of wall and make the dimensions for that particular wall. Now the dimensions for that particular wall, it can be, one second. Dimensions for the particular wall, it can have the length, you can have the breadth of the wall. These are your computing the dimensions. Now this class is wall. Attributes are the dimensions, and these are the operations that are there for the wall. Now this wall is made up of wall segments, windows, and doors. That is, within a particular wall, You're going to have a door, you can have windows, and there is going to be the wall segment. Now a wall segment, now this type starting coordinates, top coordinates, you can see that. And this next is also same for wall segment, windows and doors. That is, this is going to what type of wall it is, what are the coordinates, the starting coordinates, stopping coordinate. This means the dimensions. These are the dimensions of the wall for the window and for the door. Now next door means a particular floor is not going to have only one door or one window or one wall segment. There are going to be multiple wall segments, multiple windows and multiple doors. So for each of them, you're going to have different dimensions. And the operation is going to be the same for all. Determine the type of wall, determine the type of windows and the type of door. Now, when you're making a floor plan, you can make a use of any applications. You can make use of the computer aided devices so that you can draw the floor plan. Now, for drawing, you can make use of the draw operation. Now, the next one is camera. Now here, for the camera, when the entire wall, all of this is placed, at the end, you're going to have cameras. Now, cameras are going to have different types of cameras are there. They're going to have specific ID numbers and location that this particular area is covering. Whether it is full field view or pan angle, these are different zoom settings. What are the different options that are there for the camera? You can have all those camera settings. These are what define that describe the camera. These are your attributes. Then the operations are going to be how you're going to view it. The display ID, the display view, display zoom, translate the location or determine the type. These are all your operations that can be performed for the camera class. Now this entire floor plan, you can see that this wall segment, windows and doors, this wall segment is used to build a wall. Windows are again used to build the wall and door is also used to build the wall. That is, within the wall, all these three things are incorporated. And this wall becomes the part of the floor plan. Whereas cameras, when this entire floor plan is built, these cameras will be placed within the floor plan. So this is the class diagram. Now this class diagram, you can either get it for 10 marks, or this class diagram you can have this question for explain the class diagram for 5 marks, and another 5 can be for CRC modeling that we'll be studying. So moving on to class responsibility collaborator. So this can be asked for 10 marks or for 5 marks. Now, based upon that, you need to write down, you need to cut short the content. Now, cut short the content means all diagrams need to be present. All side headings need to be there. Now, cut shorting means if suppose there is more content in here, a lot of content is there, you can select some specific content and write about that. You can leave a few lines, but the others need to be there. Now, coming on to the class responsibility collaborator, also called as the CRC. Now the CRC modeling. Now what is the CRC modeling? CRC modeling, it is a collection of different standard index cards that represent the classes. Now you're going to make use of index cards. Now what are this index card is going to look like? This card is divided into 3 different sections. Now what are going to be those 3 sections? Let's see that. Now this is your have the class name in here. So now within this, cards are divided into 3 sections. Now within those 3 sections, now the first section, the top of the card is going to be your class name. You're going to have the class name. Then in the body, that is the other part, you're going to have the class responsibilities on the left. That is here, you're going to have the responsibilities. And at the right side, you're going to have the collaborator. Now, we've already seen this CRC model index card as example within the previous models within the first unit. So this is called as your CRC index card. Now within this index card, now if we take the class name, if we take the class name as, if we take an example for ATM card, so class name can be card reader. The next one is responsibility and collaborator. Now within the first responsibility, if we take that, tell the ATM that the card is inserted. So the collaborator for this is going to be ATM. Who is going to know this? The ATM is going to know this. So this is your first task. Then the second one, if you say that reading the information, then eject card or retain the card. That as reading information means once you've entered your PIN, it is going to validate your PIN. Eject card means after you've done the transaction, it is going to give you the card. Retain card, if you have entered some wrong number of inputs, then it is going to retain the card. So this collaborator, these three tasks collaborator, it is done by the card. So this is an example for CRC. Now, if we take the same example for the floor plan, we've got the CRC model index card. Now this index card, you've got the class name as floor plan. You can have some description written, responsibility and collaborator. Define floor plan. This is one responsibility. Managing the floor plan positioning, scale floor plan for display. Now for this, you've got no collaborator. Whereas incorporating walls, doors and windows, this collaborator is wall. That is, this task is done within the wall. The wall has got the walls, doors and windows. Whereas for the camera is going to show you different views of the camera and different thumbnail view. You can have the entire camera view or the field view is there. The zoom settings, this all is done by the camera. So this is a CRC model index card. You can take any other example based upon the time and marks. You can either take the example for ATM card reader or for this floor plan. The next is the classes. Now there are three different types of classes. You've got entity class, boundary class and controller classes. Now this entity class is taken from the problem statement. From the problem statement, you get this entity class. Now, what is this entity class is going to hold? This represents things that are stored in a database and persist through the duration of application. Persist means they are going to remain throughout the duration of the application. When you've stored some data within a particular software, so until you use that particular program, until the execution is done, that particular data is going to remain within the database. That is called as your entity class. Then the next one is the boundary class. So this boundary class, it is used to create an interface. Now what is interface? Interface is how you interact. It is designed with the responsibility of managing the way the entity objects are represented to the user. Now interface, it can be the graphical user interface, the GUI interface, how the user is accessing the different objects or different functions that are there for the particular software. How you're accessing, that is done by the boundary class, what type of interface you're using. Then the last one are the controller classes. Now controller class, as the name says, controller means it is going to manage one unit of work from the starting till the finish. Now, what are the different types of works? Or the controller class is designed to manage, it is going to manage these different types of tasks, that is creating or updating an entity object. That is, you're adding any other feature within the software. Representation of boundary classes, that is the interface, how you're interacting, what are the different functions that will be present within one specific object. Then complex communication between set of objects. If there is any complex communication, then that is done by the controller class. That is, the controller class is going to manage this communication. And validation of data, whether the data is correct or it is incomplete, this all is going to be managed by the controller class. Now this three different types of classes, this answer can also be asked for 2 marks. Then the next one is responsibility. Now within CRC, we are going to study all of this three. First, classes we have completed. Next is responsibilities. Now for responsibilities, you've got a basic set of guidelines so that you identify the different responsibilities. Now the system intelligence should be distributed across classes to best address the need of the problem. Now system intelligence means you're going to have different applications. Now this different applications, they have got some degree of intelligence. That is, they understand a few things, or they understand a few things better than some other application. So this degree of intelligence, this should be distributed across this different classes. This intelligence, it should be distributed across the different classes. That is your first point. Then the second point is each responsibility should be as general as possible. Now responsibility, it should be general means when you have got different general responsibilities are present. So these general responsibilities, they should reside high in hierarchy. That is, general responsibility means like an overall view, a brief representation, it should be present at the, now if there is the hierarchy, they should be present at the top level of hierarchy. When you've got more detailed description, then you can go down the hierarchy. The next is information and behavior related to it should reside within the same class. Now information, now if you've got different data and you're going to have different processes. Now this different data and processes, they are used to manipulate the data. Now when you're manipulating this data, now this data and process, they are specific for different classes. Now these all data that is manipulated, this all need to be packaged as one cohesive unit. That is, it should not change any other information within any other class, that they need to be packaged. Then the next one is information about one thing should be localized into single class, not distributed across multiple classes. That means that if you've got one single class need to take the responsibility for storing and manipulating the data. It should take the responsibility for storing the data or manipulating the data. Now this, why it should be localized to one class? If suppose multiple people are given the task for storing and manipulating data, then it becomes very challenging to test and maintain the data. So that you have testing and maintenance should be easy. The last point is responsibility should be shared among related classes when appropriate. Now this means that now in here you're isolating the behaviors, but sometimes when you've got same responsibilities, you can share those responsibilities that has got same behavior. So these are the guidelines for responsibility. The next one is collaborations within the CRC. The last one is collaboration. Now within collaborations, collaboration represent the query from client to server in fulfillment of a client responsibility. Now this classes fulfill the responsibilities in two different ways. So those two different ways are a class can use its own operations to manipulate its own attributes in fulfilling a particular responsibility. And the second one is classes can collaborate with other classes. So what are these two things? These two things are classes fulfill. Class is going to fulfill the responsibility in either of the two ways. A class can make use of its own operation to manipulate its own data, or it can collaborate with other classes. That is, first thing is he can make use of that. Every task can be done by himself, or he can make use of some another person. The job is done by itself, or it is done by help of other class. So these are the two ways in which responsibilities are going to be fulfilled. Now this is collaborations are going to occur between a client and the server. Client to server fulfillment, that is done by the two ways. One object correlates with another object if it needs to send some SMS to other objects. This is the second way of communication. Now it identifies the relationship between objects. Now what are relationship? How the two objects are connected, that is called as relationship. This particular link is called as your relationship. Now these collaborations are identifying by determining whether a class can fulfill responsibility or it can interact with another class, the two ways. So this link will be identified by either making use of the two things. Now within this collaboration, this is one example for identifying the different classes. So this arrow in here, or you can say this relationship in here, it is called as your composite, or you can say composition relationship, that is represented by a straight line and a filled diamond. This is your composition relationship. Now composition relationship, it means that this particular player head, player body, arms and legs, they cannot reside on their own. They need to be connected to the player. So this, whenever suppose a player, the player body, head and arms, if you remove them, they are going to be of no use. But when they are attached to the player, they have their own purpose. Now when all of these are attached, they are sharing the knowledge of relationship. They're sharing its own knowledge between the different classes. So this is the composition relationship. The next one is association and dependencies. Association is again another type of relationship. Now within this, association can have multiplicity. Association is represented by a straight line. This means that there is direct link between the two different objects, between two objects or two different objects. Now this association, it can be either one to many, it can be many to many, or it can be many to one. So this is multiplicity relationship. We are taking the example of floor plan where wall segment, window and door are attached to the wall. So within this, you've got this wall segments, windows and door, they are used to build the wall. Whereas this relationship in here is one to many. Windows is zero to many. You can either have no windows within a wall or you can have many windows. Door are again, you can either have one wall or you can have no walls. So this is your association relationship and this is the multiplicity. Coming on to the dependency relationship. Dependency relationship, it is indicated by a dashed line with the arrow. Now this dependency means that the display window is dependent upon the camera. Now if suppose you do not have the camera, then this display window it can either have, that is this particular window, it can either have the thumbnail view or it can give you one view. So this view is not useful until you have a camera. And so this is that this dependency relationship, this display window is going to access the camera and this camera can be accessed, that is the display window can be seen when you enter the password. So this is your dependency relationship. Now this analysis packages, it is an important part of modeling, that is categorization. Now within packages, what you're going to do, you're going to bundle all the things together and make it into one package. You can see that within this environment package, you're going to have trees, landscapes, road, wall, bridge, building, visual effects and scenes. So this becomes one package. Then for rules of the game, you're going to have rules of movement, constraints of the action. This becomes the rule of the game. So this becomes one analysis package. For characters within the game, you can have different players, protagonists, antagonist, and different supporting roles. So these are different packages. So what are these analysis packages? This analysis packages, these are the various elements of analysis model. These are going, this like example, you can have different use cases and analysis classes. Now these, from this use cases, you can identify the different actions and you can group them into one particular package. And these are characterized in such a way that this grouping is called as your analysis package, and you're going to give a representative name to it. That is, environment is the name. If you have some other things, you can give it in another name. And for Java also, there are different packages. Within the packages, you've got different things that are bundled together. So this is the end of class based modeling.